Alltech Chemicals is aiming to become one of the world's leading suppliers of 99.99% high-purity alumina. The company's market capitalisation increased fourfold since 2015 following the release of its bankable feasibility study for construction of a 4,000 tonnes per annum high-purity alumina plant at Johor, Malaysia. Please welcome their CFO, Mr. Shane Volk, to the stage to tell you more.
Welcome to the world of sapphires. Valuable, unmatched beauty, rarity and purity are the ultimate qualities of this precious gemstone. Virtually unscratchable, sapphires are the only natural material on Earth as hard as diamonds. In nature, sapphires are formed from high purity alumina deep in the Earth's crust. Like any naturally occurring gemstone, heat, energy and pressure over millions of years stimulates the growth of these natural sapphire crystals. Today, mankind has the technology to recreate the formation of sapphires using high purity alumina under intense pressure and heat. The formation takes place in high-tech furnaces where large single sapphire crystals are grown from high-quality alumina. From these crystals, sapphire wafers and sapphire glass are extracted using diamond cutting technology. These synthetic sapphires, like the natural sapphire gemstones, are highly valuable and prized. Today, synthetic sapphire is playing a large and growing part in our everyday modern lives. Sapphire wafers are used in the manufacture of cost-effective, energy-efficient LED lights. LEDs, the lighting of the future, offer huge energy savings and are rapidly replacing traditional light globes around the world today. Semiconductors in our electronic devices, phosphoroplasma televisions and scratch-proof watches are some of the many applications that belong to the sapphire family. Smartphone manufacturers are already making the exciting transition to the unscratchable sapphire display screens. We all look forward to a sapphire future of unscratchable glass. To meet this sapphire future, Alltech Chemicals, an Australian company, is aiming to be the world's leading supplier of high-purity alumina. Alltech has rapidly grown to consolidate its strategic advantage through the rapid development of its kaolin mine in Western Australia and its proposed high-purity alumina chemical facility in Johor, Malaysia. The company's proposed state-of-the-art production facility will produce high-purity alumina, specifically designed for the synthetic sapphire market. Well positioned in the Asia-Pacific region, customers around the world will trust the quality and reliability of Alltech's high-purity alumina products. Alltech's proposed expert customer support and state-of-the-art packaging and distribution service will be second to none. Alltech Chemicals is aiming to be the leading supplier of the key ingredient for sapphire glass, high-quality pure alumina. Alltech Chemicals, meeting a sapphire future.
Thank you, ladies and gentlemen. It's a pleasure to be here this afternoon and present Alltech Chemicals to you. Alltech's a Perth-based company, listed on the ASX. Our code is ATC. Current market capitalisation is around $40 million at a share price of 14 cents. And we're on our way to becoming a world-leading producer of high-purity alumina. We're planning to commence construction of our HPA plant in Johor, Malaysia in the second half of this year. Now, high-purity alumina is a product that you probably haven't heard of. I certainly hadn't before I joined Alltech, but the items it makes or it goes into are surround you every day. The main one being LED lights. But also your iPhone. If you have an iPhone, the home key and the camera lens are all made of synthetic sapphire. The ingredient for making synthetic sapphire is high purity alumina, and there's no substitute. High purity alumina commands a price of around $23 a kilo or $23,000 a tonne, and demand is growing rapidly year on year, around 24-25% a year. And again, it's all about synthetic sapphire. Now, as we saw in the video, synthetic sapphire is made by melting high purity alumina. Basically, you introduce high purity alumina into a kiln, which is there on the left-hand side, heat it up to around 2000 degrees centigrade, cool it down over 21 odd days, and you're left with a huge synthetic sapphire bull, which is on the right-hand side. From the bull, synthetic sapphire wafers are cut, and it's these wafers that form the substrates of an LED light. And the usage is around 20 to 25% of that wafer will go into a finished product LED light. Or alternatively, polish those wafers up and you can get a smartphone screen. Several of the Asian smartphone producers such as Huawei and Vertu have introduced sapphire glass smartphone screens. So that's the actual screen of an Apple Watch. So if you have an Apple Watch, you can try that at home. Just demonstrates the scratch resistance of synthetic sapphire. And many high-end watches, this is a Tissot watch. Many of the high-end watches already have synthetic sapphire screens on them or faces on them. Now the blue sky for high purity alumina is lithium-ion batteries. The coatings of the cathode sheets and the anode sheets and also the separator sheets are now being coated by high purity alumina. And this is to stop basically the anode and the cathode coming into contact with each other and thermal runaway. And we've all seen through the Galaxy Notes what happens if there is not a competent enough separator between the anode and the cathode. Battery goes into thermal runaway, the battery catches fire and explodes. So high purity alumina is increasingly being used to coat the anodes and cathodes and the separator sheets in these batteries. It's a very small market, but it's growing rapidly. Look, high purity alumina is not a new product, it's been around, but traditionally the producers are just small business units within very large industrial conglomerates. And some of those producers you'll recognise maybe they're Sasol, Hebei, Sumitomo Corporation. But what these current producers do is actually buy aluminium metal and then they reprocess it. Problem with aluminium metal is it's got sodium in it and they need to remove the sodium to make high purity alumina. It's quite an expensive process, and those of you that understand the aluminium production process know that it starts off at bauxite and goes through to smelter grade alumina through to aluminium metal. Our process is a single step process and it's going to change the cost curve of producing high purity alumina. We basically take aluminous clay, we ship it up to Malaysia, 40,000 tonnes a year, and from that we produce 4,000 tonnes of high purity alumina at a cost of around $9,000 a tonne versus the current producers between $14,000 and $16,000 a tonne. We can do this because of our beautifully clean kaolin deposit in Meckering, which is about 130 kilometres due east of Perth. High in alumina, 30-odd%, but basically no impurities. The only really other thing in the deposit is silica sand. Work on our project started in 2011. We're using open technology. The HCl leaching process has been known about since the 1980s. We've just picked up that process. We've calibrated it to our deposit at Meckering and done test work, proven it works, and we're now ready to scale up to a full-size plant. So really we're taking existing technology, we're taking a wonderful deposit that we're blessed with in WA. We've got experienced people. Iggy Tan is our managing director. He's the guy that set up Galaxy Resources 10 to 12 years ago, and his right-hand man in that company has joined us as well, Jinmon Liu. And we're selling our product into a great market, a market that's growing 25% a year. These are a few shots of our Malaysian plant, which we've just finished designing. It's in final design. We've got a German EPC design company and a German contractor building the plant in Johor, Malaysia. This is the results of our BFS. The financials are compelling and they speak for themselves, but I'll let you read the key numbers, which is a capex cost of around $80 million a year. Pre-tax NPV at 9% is around $360 million US. The rate of return is 33%. And operating costs we estimate at $9,000 a tonne, selling the product at $23,000 for a margin of $14,000 a tonne. This is where we sit on the cost curve. This is just putting us against the established producers, and you can see we're nicely positioned on the left-hand side at the lower end of the cost curve, and we're right up there in purity, which is where you want to be. It's one thing to produce the product, it's another thing to sell it. We've partnered with Mitsubishi Corporation, a great Japanese trading house. They've agreed to take the first 10 years of product and place that for us. They've got an extensive network in Taiwan, Japan, China of course, which is where they'll place to the lithium-ion battery industry, but also into the synthetic sapphire industry. We're funded by the German government. 60% of the plant is German technology. It's clean room technology. The Germans have a great export credit finance scheme. We'll get money at about 4 to 5% over a 10-year term for the majority of the debt. The debt term sheet should be finalised by the end of this Q2 this year. The Germans have conducted the most amazing detailed due diligence on this project. They've been through the plant from the front to the finish. It has taken longer than we expected, but I think for shareholders that gives you great comfort that this project has been looked at by bank-appointed independent consultants, German government, and we understand the depth of the due diligence because we're effectively using German government money. As I said, the path forward is that the debt term sheet will be finished at the end of Q2. We'll need to raise some project equity to put next to the debt. Site works will commence sometime, hopefully during early Q3 2007. There's an 18-month construction period. Our first product of HPA should be on the market by 2019, and we should meet the beautiful rising demand curve for our product. So we truly believe that we are in the right place, the right time, with the right product and the right technology. So I'll be here for an hour or so after the event if you want to come and ask some questions. So thank you very much.